So I will be recording now. So hello everyone, and this is actually the recording for week 6. As I mentioned, there is so many questions in this tutorial, and the purpose I put all those questions because we don't have tutorial, we don't have workshop, and I want to have enough coverage for this area, which is liquidity, very important. If I couldn't finish the recording in this tutorial, then in this case I will have to do a private recording. Now, if you allow me, I will just start writing, and this is what we are going to do today. So actually, we are talking about this is tutorial number, as I said, and I want to cover the following issues in this tutorial. First, liquidity causes, which we already know it. Number two, we will have to talk about addressing this liquidity. But also we will be introduce ourselves this time to something called NDD, which is net deposit drain. This is very important because it will measure our liquidity. And actually, it will show us whether our deposits are increasing or decreasing and how that impact the liquidity. And this is net deposit drain is coming through this. So we have deposit withdrawals minus deposit additions. This is the formula of it. Now this number can be either plus, minus, and 0. If it is plus, I am not happy because deposit withdrawals is higher than deposit drain. If it is minus, I'm happy because deposit additions is more than deposit withdrawals, and the size of the bank is increasing, while here decreasing. And here no impact. This we want to understand it because there is some type of normal distribution. We will use this class to this tutorial to understand it. Then we will talk about another issue called core deposit, which is actually related to the net deposit drain. And after we talk about this, we will move to the measurement. Now we have 6 types of measurements for this class. One of them is actually we will use today net deposit, net liquidity statement. This is one, and we have liquidity index. These 2 measures, we will talk about them today. And then we will talk about something called liquidity and other financial institutions. Especially today, we will go talk about mutual funds, mutual fund liquidations. And we will see what we can do with this and then finally, we will talk about the management of liquidity, management of liability, okay, which is the most important thing to finance liquidity. And we will talk about the risk return risk, cost, relationship, and we will go to the old thing, which we call it the trade-off. Which will lead us, our measure there is to increase shareholders' wealth. Hopefully, I will be able to manage to go over all these points. Let's go to the first point, which we have talked about it. Liquidity can come from, it's of course because of the transactions, because of the economic and financial transactions, the bank, people deposits, people withdraw, people take loans, all those issues is happening in the asset side and the liability side. And therefore, sometimes I am stressed under liquidity because there is an expected withdrawals, like when we have from the asset side, we can have a loan commitment. Now we can always disclaim, what we call loan applications, except for loan commitment, which is based on a contract few years ago, and we have to execute the loan now. And if we don't execute the loan, we breach the contract. It's a promise that we have to carry out. So otherwise, we will be an contract breaching status. So this is coming, which means we have to manage funds to finance this loan, which we already committed. And number two, which is the normal life, the liability side. The liability side, which is those, especially when we talk about 60% of our liabilities is coming from the deposits, the retail deposits, saving accounts, current accounts, and all these things, and also from the creditors. This is like bonds. Okay, but most of it actually, this is bonds, people who buy our bonds, and we have to, and other creditors like interbank and other things, but mostly is the depositors. So all those claims have to be paid. Especially this one when it comes through unexpected behavior. For example, there is some economic changes in the market, depositors started to withdraw, and this unexpected withdrawals will stress my liquidity. Now, as we said before, so liquidity, as we said, it can come from the asset side, and it can come from the liability side. We understand this, some of loan commitment. The problem is to how to address it. Usually, how to address the liquidity is to address it through purchase liquidity, which means we go and borrow. And this is the normal practice. But if we cannot do this, and it happens some of the times, if we cannot do this, we have to go to our assets and sell them, and we do it under something called stored liquidity. This is just selling our assets. Selling our assets, okay. The problem is when we sell our asset under stress and we are rushing, we go to something called fire sale. Now, fire sale is a problem because fire sale, you will sell your assets less than. So if you look at the fire sale, always less than the fair market price. So I have stocks or bonds or whatever, and then I'm under stress. So if for example, if I have stock of $13 per share today, and because I am rushing, I will sell it only for 12. Okay. Now this has nothing to do with the purchasing price, which I could have put this for 10. And then by time it becomes 13. This is another thing, the purchasing price. I could be okay, selling it with 12 is okay. But the problem is I am looking for the asset price. The asset price now is already 13 and I should get 13, but I sell it for 12. So this is where we take us to, so I said when we address liquidity, according to this issue, we can address it through asset and liabilities, but sometimes because we don't have access to the borrowing, we will sell our assets and it had to be immediate selling and it will be cheaper than the market, which is less than market. This is one point. So I am actually done with this issue. Now let's move second thing to the something called core deposits. Now core deposits, it's this type of deposit. For example, if you have saving account, if you receive 1,000 RM from your parents and you are living here in KL, studying in Monash, this is the monthly statement, the allowances. So you may spend, nobody will spend 1,000 exactly. Usually by the end of the month, when they send you the second month, you have something like 100 in the account. Even if they send you next time 1,000 and you spend the whole 1,000, you still, most people will have 100. This also applies to corporations. This is individual, for example, like you and mine. Also, when I receive my salary, I don't spend it all. There is something which is core. Corporation, for example, take a current account for a huge corporation. This current account could be 50 million, something like Petronas. Now, Petronas, when they manage those current accounts, they may withdraw up to 40 before they top up again. They have something like 10 million, 5 to 10 million still all the time. Now, this is actually core deposit. So as you can see, as long as the client with me, the customer with me, this will not be withdrawn. This will not be withdrawn. If you are a public bank customer and you are a student, mostly you will have 50 to 100 ringgit. When you go to work later on, maybe you will have around 500 ringgit in your account, that if you are not savings. But in these accounts, this is called core deposits. So it's a stable source. It's a stable source, and those deposits will stay with the bank over an extended period of time. We are talking whether you are talking about demand or saving or retail deposits, and those people who come and withdraw their money usually from us. So these ones, even they are, although they are demand and savings and all these things, but actually they have this type of deposits. They have this core of deposit, which I told you, it's a small amount that stays for a long time. Now, this one is very important because it has a higher level, if you have a higher level of core deposits, that will increase the predictability of forecasting the net deposit drain, which means I come with you to this statement. This is the net deposit drain. Which means the deposit additions, the deposit withdrawals will not touch it, will not touch the core deposit. So if the core deposit is high, which means I can expect this to be an increase. I don't expect, a drop or a huge drop in my deposits, because if I have huge core deposits, then in this case, it's part of the deposit additions that will stay for a long time. This is why we are saying here, they increase the predictability. So net deposit drain, as I said, deposit addition, deposit withdrawals, minus deposit additions. This part of the additions that will not be withdrawn is called the core deposits. This is, as I told you, so the core deposit is part of the deposit additions that will stay for a long time. Okay, now let me go to the next question. This is maybe a new issue, and we have talked about this. There is a relationship between what we call the maturities of the assets and liabilities, and this is the fact of life. When we talk about, we have talked about this before, which is maturity intermediation. But now, when it comes to liquidity, we understand that the maturity of assets all the times will be higher than the maturity of liability. Give me an example. I will give you an example. Say, for example, housing loan. The housing loan, a normal housing loan, 20 years. A normal, look, a minimum one. Here, a maximum liability is actually long-term deposit, which is 5 years. So when the 5 years end, because the money of these people actually is locked up here. So if it is locked up here, when it ends, either these people will renew with me, or you can find another deposit to deposit, another depositor to deposit, and then I can settle with these people, or I have to settle with these people by selling my assets. The problem is if I have to reach to this point, which is I have to sell my assets. If I sell my assets now, that means I go to fire sale. And we already talked about this crazy thing called fire sale. So this is what's happening. So as we said, the question is how the financial institution liability and liquidity risk management problem related to maturity of its assets and liabilities. First point, the maturity of assets is greater than the maturity of liabilities. This is the facts of life. We accept this. Housing loan is higher than this one. Number two, as the difference in the average maturity, if this difference increases, then in this case, there will be a liquidity risk. Liquidity increases. Now, in the event that if they don't renew, the investor are not reinvesting, the financial institution may need to liquidate some of its assets through fire sale. Now, the problem with the fire sale, as I told you, fire sale usually less than the market price, which leads to losses in the same. It's not losses from my operating price, but losses because I sold my assets less than the market price. So this is when we say how the maturity, how the nature of this maturity of assets and liabilities will affect how liquidity is affected by maturity. This is what I want to say in this stage. If you understand it, yes, it will affect it because it may stress up the liquidity more. And if I cannot get purchased liquidity, which means let these people invest with me again or find some other people, I have to go to the stored liquidity, which is my last resort, sell my assets, and usually I will sell them with fire sale that is less than the market price. That will take me to losses. I'm finished with this question. Now, let me go to the most technical thing in this class, in this tutorial. And if you allow me just to, I didn't have space here. If you allow me to Look, this is how we predict liquidity. Liquidity, and like most bank risk, cannot be predicted. It doesn't have trend. It doesn't have trend. In other words, we cannot say, well, last month the withdrawal was like this month is higher, the next month is higher, or you connect it to any economic indicator. You cannot do that. So we use it's random. And the way we predict it is using this, our friend, which we talked about it now 3 times. Somebody is asking about the WhatsApp group. Okay, so now when we talk about random, we have to use what we call net deposit drain, which we have already talked about it. Now the net deposit drain which we will call it from now NDD, is actually deposit withdrawals minus deposit additions. Okay, we understand this, and we have talked about it, and we said this can be plus, minus, or 0. If this is the situation, now come to any bank. Normal banking day, if this is the banking day, this is daily basis, huh? This is daily banking. So daily banking, if we have the daily banking like this, and this is the change, which is here, this is percentage of this, we measure it as a percentage of deposits. And we want to predict what we call the liquidity. We have 1 day, 2 days, 3 days. For example, we take only 1 year. We can take, so 1 day is 250 days. Now, if you come here and you calculate this in daily basis, maybe the first day you will get it 2% plus. Then next day, because it's random, maybe 2% minus. Then we get 0. Then suddenly we get 4%. Then we drop to maybe 6%, and we continue like this. If the average is 2%, I can now calculate the mean, which is 2%. And if I can calculate the parameter, this parameter, I can calculate also the standard deviation of this observations. If I can calculate the standard deviation, assuming it's 1%, then in this case, I'm ready to build this normal distribution. I need only those 2 parameters. So maybe this is, it's not normal, because if it is normal, it should be 0, the mean. But this is not, so this looks, this looks like this, a little bit skewed. So if this is 2%, I just want to know from stat6 the following thing: the Z value, which is 196,164. This, if you don't understand it from stat6, understand it from me now: 164, 196, 256. This is equal standard deviation, 1 standard deviation, 2nd standard deviation, 3 standard deviation. This is 196. And the confidence level is actually, this is 90% confidence level, 95% confidence level, and 99% confidence level. Now, if your boss give you this data, or you collect this data, and they want to predict the increase or decrease in deposits for next year, So they want to see the stress on liquidity. In this case, if you, based on this and this, you know this is the, you know this is 3%, and you know this is 4%, and you know this is, because this is the plus, this is the minus, right? And this is 1%, and this is 0. And this whole area, 95% confidence. Why? 2 standard deviation, 1, 2. I can increase it to 3 standard deviation. Now you are ready to report. The report will be like this. If you are a team, you say, we expect decrease in deposits. Now, if the mean was minus, you will say increase in deposit. Or you can say just the change in deposit to be between 0 and 4% with 95% confidence. Finish. Nobody can talk to you. This is not your numbers. This is not your method. This is a random behavior. Your assumption should be very accurate. There is no judgment in this. Very technical. Okay. Now, having known that, let me now, as a manager who are managing liquidity, let me bring you to the next question. Now, the next question should be easy. Here they say the probability distribution of the net deposit drain has been estimated. You can say this, probability distribution for maybe you are taking 2 years, 3 years. We are just taking 1 year here. Has been estimated to be 2%. When they say 2%, you already know it is, that means deposit withdrawals higher than deposit drain, deposit additions, because it's plus. Don't mix. Okay, plus is no good because deposit withdrawals, according to the formula, is higher. So they say 2% and the standard deviation is 1%. Now, if this is the, is this the deposit institution increasing or decreasing? This deposit institution, this DI is actually decreasing. Why? Because of this number. So this bank is decreasing in size. Why? If you look at the balance sheet, the deposit here and the asset is here, this one is dropping, which means the total liabilities is dropping, which means the total assets is dropping. All this size is going down. This is why we are saying decreasing in size, because less core deposits being added to the bank. Now, on average, the rate of decrease of deposit is 2%. The average, but if I tell you with 95%, that the rate of decrease of deposit will be between 0 and 4%, which is this area. We expect decrease in deposit to be between 0 and 4%, which is this area. Now, if you are talking about 99%, so you will just say add 1 standard deviation here because you are doing, so it will be between -1 and +5 if it is with 99%. Okay. Can I have green light to move from this area, please?
Yes, sir.
Okay, thank you. Now, let's go to the, how is the deposit institution, how DI distribution patterns of net deposit drain affected by the following. Now, look, just manage with the net deposit drain. Okay, net deposit drain, when there is holidays, think about the formula. Net deposit drain, we have withdrawals and we have additions. So when there is Chinese New Year, when there is Ramadan, like now, Eid al-Fitri, Deepavali, Christmas, all of those is areas, seasons where people will withdraw some money because they won't spend. So we expect the net deposit drain for we expect the deposit withdrawals to be higher than the deposit additions, which means I expect the to be plus. And therefore, I can say if there is, I expect if we were zero, for example, this is the normal distribution before the season when it was zero. If there is deposit additions, if there is seasons where there will be more deposit withdrawal, I expect this graph to shift a little bit and become the green one. So we expect it to move to the right. So withdrawals, spend more river, the standard deviation decrease, the distribution narrows. So we expect the distribution to shift to the right. Okay, based on this, if you are, I told you in liquidity, summerification also people would withdraw. They take their families, they travel to those islands, they go outside the country, inside the country, there will be more spending. So actually, the deposit withdrawals will be higher. So we expect the same thing. If it was like this, if the distribution was like this before, we expect it to move to the right because the plus minus will increase of the deposit, because this distribution reflect the net deposit drain, which is the level of liquidity, a level of decreasing or increasing in deposits. So this will be moving to the right. Okay, you are, I told you, if you are a banker, and of course you are aware of the economy around you, if there is an economic recession, they will tell you what happened is people don't have opportunity cost. They have a lot of cash. The market is dead. You don't know where to invest. The last resort is the bank to put your money. So that will actually increase deposits, additions. Because you have deposit withdrawals minus deposit additions. Here you have the NDD. So you expect this to increase. If this is the increase, which means now this will be minus, which means we expect this to go to the left because the distribution is just like this. The distribution, as I told you, is just like this. This is the plus and this is the minus. So it will move to the left. And this is it. Okay, what if there is a recession, inflation? If there is an inflation, yes, people will withdraw their money, and maybe they will need to withdraw more money because spending for the same goods and services will be higher because your dollar or your ringgit is now buying less. That's true. But usually when there is a recession, the government will take an action and they will increase the interest rate. So to absorb the liquidity from the market and play with the money supply. And when they do that, they will actually increase the interest rate. So when interest rate increases, it will give you a more motivation to put your money in the bank. So again, deposit. If you look at the formula, deposit additions will increase. And therefore, if this is deposit withdrawals,
decrease.
yeah, deposit withdrawal, deposit addition. Yeah. So this one will increase. This one will decrease because the deposit additions will be more. Yeah. So minus, so this will go to the left. And this is what we are saying. Inflation may cause general flight from money that will cause the distribution to narrow. The entire distribution shift to the left. So now those four scenarios, I want you to be aware of it. This is just to express the behavior of the depositors, and also you integrate it with some economic, directions. Okay. Now we are going well until now. Hopefully I am okay. So we will go now. This is the most technical thing. If there is no question, I can move. Can I move? Or if you have small questions, whatever, I can answer it. We still have 22 minutes until the end.
No for me, sir.
Okay, thank you. If anybody else, they can chat. Okay. Now we go now to something called net liquidity. Net liquidity statement is one of the majors, and it's very easy. You just have to have the sources minus the uses. And will be, for example, this you have these uses, you have these sources, and then you will have here net liquidity. So I will give you a digit here. If this digit is plus, you are happy. I mean, you will not need to borrow. I mean, this is your capacity to borrow, because net deposit drain will tell you this is all the sources you can borrow from. This is all your liabilities before you touch your assets. So in this case, I can borrow 10 million T notes. I have a 10 million T notes. I have 5 million line of credit. I can borrow it. I can borrow from central bank for 5 million, which means my resources now can come up to 20. 10 plus 5 plus 5, 20, which means this number is 20. And my uses is I have currently has borrowed 6 million, which means I have to pay it later on. And I have another borrowing from the repo repurchase agreement of 2 million. So I have 8 million, which means now I have 8 million. This is the uses. Which means make this one 12. What does it mean? We understand this is just third grade calculation, but what does it mean? It means I can manage with sources from outside, because as I told you, when I address liquidity, I address it through the purchased, which is the normal practice, purchased liquidity, or I can address it through asset, which we called stored. Now, I can up to here address 12. This is what they are saying. After the 12, I have to go to the assets. That's fine. So what's the problem with the assets? The assets will take me to do fire sale, which actually I don't want to do. So in this case, we understand that this is 8. We understand that we have the net liquidity is 12. So what's conclusion? The conclusion is the net liquidity of 12 million suggests that I can withstand unexpected withdrawals up to 12 million without having to reduce its liquid assets at fire sale price. This is the translation of what we mean by this one. Okay, so net liquidity will give me my net liquidity position, and my net liquidity position, if it is plus, That means this is the maximum or the ceilings where I can, or the roof where I can borrow before I touch my assets and sell them in fire sale. Okay, so now we have understood this. We will go now to the second measure, which is actually this one. Now this one is actually, they are telling me this is Fund A, and this is Fund B. Now Fund A and Fund B, just give me a minute. Fund A and Fund B, this bank is under liquidity, and they have this portfolios. Which one they should sell? The rule is I will sell the one that will give me the most liquidating value. So we have to calculate it. So when we calculate it through what we call, this is the formula, liquidity index. Liquidity index will tell me how liquid I am. So I want to see the more liquid one and sell it. So I have 1, 2, 3, which is one asset, two assets, three assets. I want to see their weight, and I want to multiply them by liquidating value over the face value, which is this one, when I liquidate after 1 year. This is the liquidating, this is when I liquidate. Don't look at this figure, look at this and this. So now to calculate this one, I have to, for A, if you take the average, now what is the average? This is 30,000. So the weight of this is 33%. This is 17%. This is 50%. You just divide 30 by 10, 30 by, 10 by 30, 5 by 30, or 15 by 30. This is the same actually. This is actually 33%. This is 17%. And this is 50%. Now, Fund A will be like this. The weights, as I told you, so we have 33% for asset 1, plus 17% for asset 2, plus 50% for asset 3. Now I just need to get the, so I have 10,500, this one. No, excuse me, 9,900 over, this is the BI, because I'm using this formula. This is the BI, and this is B. This is the BI star. This is the BI, and this is the BI star. So over 10.5, this is 17, which is 4,000 over 4,500. This is 15, which is 13,000 over 14,000. And I find this to be 92.65. Meaning if I liquidate, I will get 92.65 of the values of the asset. Fund B, which is actually the same weights, I just need to get the VI, and so this one is actually 9,000 over, which is this one over this one, and this one over this one, and this one over this one. And find this to be 90%, 158. Decision, liquidate Fund A because gave more liquidating value. Okay, so I am done with this question. Hopefully my computer will help me now. I don't want problems with it. Okay. Okay, so this is actually the question, and it said it has higher liquidating value. So all this calculation is actually in this slide. Okay. Now let me go to another calculation, which is now I want to go to this point. Oh, my Surface Pro now, it will be okay, it will be okay. We just wait for it a little bit, just because. Okay, we come now to this problem. Now this problem is a mutual fund. When we talk about mutual fund, you remember bank run, when we have liquidation, in bank run, first come, first served. In mutual funds, we have to proportionally distribute. After liquidation. So we have two assets. Look at this one. We have this fund have 40 million in fixed income and 40 million in stocks. Now, if they liquidate in 2 days, which is very fast, they will receive 96%. If they liquidate in 4 days, it will be better and they will receive 98%. So we have two investors, A and B, who owns 5 and 7%. We want to know how much they will get. So in the first case, when it is 2 days, so this is 96, they get 78. So from that 76, we will now distribute proportionally. You will have 5% for one of this, and you will have 7% for the rest, for the second one. So, and this is what's happening, 75%. This is they receive 384 and 537. Now, if we liquidate in 4 days, the case will be better, and we will liquidate with 98, and we get this 78 for it. So they will get again 5% of this customer investor one and 7% of this. So they will get now 3.92 and 548. This is the whole thing. So this is just a drop for them from 4. They used to have 4 and they used to have 5.60. Now, same thing here, which means this is how the other financial institutions distribute their asset in terms of liquidation, not like the bank, but they liquidate all the assets and they proportionally distribute it among the investors. Okay, so I am done with this issue. Let me go now to, I think, this question. This is a theoretical question and said discuss the funding risk versus cost when when within the context of liability management. Look, CDs is type of financing we can finance. Retail deposits is another type, but this one has a random behavior. They can come to the bank and withdraw anytime from the bank, from the ATM machine, from interbanking, from anywhere. This CD, we issue it for 1 year. So customer will come up to us after 1 year. But if this investor is stupid to keep this money for 1 year? No, he can trade the CD. They can trade it from 1 to 1. They discount it you can discount it after a few hours, and then somebody will. But end of the year, you will buy it. The bank will pay it. So actually, this is for the bank. It gives him long time. So the risk of the CD, as you can see, this is the risk of withdrawals or liquidity risk. This axis line, and the y and the y-axis is actually the cost. This one we give something 6% to 8%. This only we give 2%. So this, as you can see, cheaper but riskier. This is more expensive but less riskier. This is the trade-off. Of funding cost, further funding risk. So you have also to model this and see how that impacts the shareholders' wealth. We didn't talk about the shareholders' wealth, but we say here there is a trade-off. This is the trade-off between funding cost and funding risk. I think I will stop here. It's now 54. I don't think I have this can, I think I covered it all. Hello, can you still hear me?
Yeah, sir, I can hear you now.
Yeah, because I don't know what happened. Did you hear the whole tutorial?
Yeah, but yeah, we did. But at the end, we can't hear you. So yeah, it's all good. After you finish, and we can't hear you.
Oh, so
Good
I
timing.
did the recording. Okay. Yeah.
So the recording is good.
Yeah.
After you finish it, and we cut.
Oh, okay.
So it's good timing.
Okay. Okay.
So it's all good, I think.
Okay. Then if there is any question you can ask, I think I will just upload this one, hopefully, and hopefully it will be useful.
All right.
Okay. Do you have any question, Ryan?
Right, sir. So actually, I'm Woon. I'm Woon, actually.
You're okay. 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 Well, thank you very much. Yeah. Okay.
All right, sir.
And good luck in the exam. If there is any question, just
All right.
yeah. Okay. Any other questions?
Yeah.
The rest of the guys? They are. Okay.
Bye, sir.
Okay, bye-bye.